Kankakee River State Park follows the Kankakee River for a pretty long stretch. It's a very narrow park, but very long. There's a lot of campgrounds, hunting, stuff like that. It's open to the public. There's no fee or anything like that. Hello everyone, this is our first stop at Kankakee River State Park. It's an overlook. What I'm going to talk about real quick here are these rocks there, and they're the same ones that are way in the background there. But what we have here is we have Silurian carbonates. We are actually near the Ordovician contact there. If we have time, we'll go look at it. But what you can see here is this is all dolostone, and here it's weathered, pretty yellow in color due to minerals like limonite and iron. And you can see the fracture patterns form nice angles. That's the Kankakee River behind me. And on occasion you have a glacial erratic because this area was glaciated, like this piece of igneous rock here. It's felsic. I'm not going to try to actually identify it. And you know, the river deposits and stuff like that, which are right here. But this stuff does have some fossils in it, but not really at this location. You can see the Silurians sticking out in cut banks and stuff like that of minor creeks, like this one here. That's where we just were, and now we're here. This overlook, you can see the Silurian carbonates. You can see curved weathering, which is mostly caused by physical weathering, you know, just the river removing rock. And in some places these fractures will actually chemically weather. Carbonates will be removed and they'll form big caverns. Not only today, but they used to millions of years ago too, and we're going to try to go take a look at that as well. The rocks that make up this wall are also Silurian carbonates, and they have some fossils. See some crinoids and stuff, but they are not from here. They actually shipped this stuff from Thornton Quarry, which is east of here near the Indiana border. Okay, this is Rock Creek. We are near where it empties into Kankakee River, which is back there. Just you can see it right in the distance. What I want to talk about here are these walls you see. They look almost like a mason did them, but they didn't. This is completely natural. But this creek, even when it's high like it is now, as you can see by how it's flowing, it's not flowing very fast. It could not have carved this valley. So what happened here? Well, you see the Silurian, you see the fractures this way, and following the creek would be another set of fractures, and they go this way, and then you see the physical weathering causing these ledges where the modern creek undermines it and things fall in. But what this was originally at the end of the last glaciation, 11,000 years or so ago, says the ice sheets retreated. This was a outflow channel, and it was higher up. As the glaciers pulled back and would catastrophically release water into the system, we were actually in an area referred to as a Kankakee turret. The glacial stuff here is mostly outwash deposits. There are diamictons and things and such, but right here, as those glaciers left, they would just catastrophically outflow water. And following fractures originally, it would just rip down and cut down until it hit a nice baseline with the Kankakee River. As we ascend this cliff, we're starting to see that past Karst development right here, but hopefully we'll be able to get a better look at it over there. Here we are looking west across Rock Creek, Kankakee River's south. Looks like somebody's set up shop there, but this is an old chemically weathered cave, modern, that is formed within the Silurian rock that you see there. We're going to try to continue north a little bit. This isn't what I was trying to show you, but I think it's cool anyway. You see this stack, this erosional remnant just sticking out of Rock Creek, waiting to topple over. This right here You know, it's a process of both physical and chemical weathering. You know, weathering following the fractures, chemically eroding things out, as well as the creek, the snow, the ice, the frost wedging, the rain battering this stuff physically. And can't tell you when this is going to fall. I can tell you that since I've been coming here for about 15-20 years, that stack was not that far out. So I give it maybe another 50 years most. And you can see there's a little tree sticking out of it there. All right, here's the thing I really wanted to show you other than the Silurian-Ordovician contact. And as you can see behind me, it's these clays. They're grayish, bluish gray, some places kind of greenish, but they're significant. And I'm going to turn the camera around and lecture you because this slope is not very stable. Okay, so me and Sarah found a vantage point to do this. I'm going to hang on to this tree for life. What you can see behind me here are the clays I was talking to you about. But you look here, clay and stuff is very brown. You see a lot of broken rock in it. This is glacial. You can see some bigger chunks of light colored rock in the gray stuff. That's Silurian, that's weathered from up higher and fallen. And actually you can't see it because I'm standing on it, but there's a Silurian ledge right here, right below this brown stuff. So what is this gray, blue, green stuff? Well, this is fill, natural fill, and an old karst. How old? We actually do know. It's Pennsylvanian. How do we know that? Because people have found shark's teeth in here of Pennsylvanian age. So what happened? Well, the Silurian ended, 400 plus million years ago, plus or minus. Then probably some Devonian deposits were deposited, but they've been eroded. So at the end of the Silurian, the seas retreated a little bit, possibly during the Devonian. So these Silurian rocks that you see here, they're strewn all about the place and form the majestic cliffs and whatnot, were exposed to dry land as they are today. And just like today, they were susceptible to chemical and physical weathering. So natural fractures and joints in the rock would have widened into caves and forming karsts, or just valleys where, big openings in the ground existed. And during the Pennsylvanian, the seas returned. Like I said, these have shark teeth in them that are Pennsylvanian, but they're also marine. Well, sharks don't swim underground. When the Pennsylvanian seas returned and put this entire Silurian section back underwater, you still had those caves, those karsts, those V-shaped, nice, angular valleys that would have been on the sea bottom now. And as clays came in, being washed from the weathering of rocks on shore and carried out to sea, they would have started filling those. Any cave that hadn't collapsed and formed a karst, which would have been filled with the sediments of the time, in this case, clay. And it stands out like a sore thumb because there's no glacial deposits around here that are close to that color. There used to be a rope, but that's no longer here. Let me see if I can. Yeah, it's not bad. Just kind of got to climb down, and once you're down there, this is where you climb down to find the contact. But first I wanted to show you this because I don't know what these structures are. I don't know if they're biological in origin or if they're like stylitic bedding or something. I'm not a paleontologist, but those are really common in the Silurian here. This is the Kankakee formation. It's a basal Silurian formation. And here you can still see some clays interbedded here near the bottom, but we're going to try to find the contact between the Ordovician and the Silurian. Sarah didn't want to go through that, and I don't blame her. But here we are. We are at the contact between the Silurian Kankakee formation and the Ordovician Nita formation, or sometimes called oolite. Okay, what's really cool about the rocks here is right here is the contact between the Ordovician Nita, which I'm going to talk about, and the Silurian Kankakee formation above. there is an erosional unconformity right here. We are still within the Tippecanoe sequence here. The thing is that at the end of the Ordovician, very near the very end, a lot of continents were clustered in the southern hemisphere. What that did was that created ice caps, dropped global sea level. I don't know if you'd really call it an ice age or not. Now, we can argue about that later, but North America was still near the equator. So sea level dropped and exposed this nita to erosion. And when it was originally deposited, it was deposited as probably a green oolitic shale and mudstone, even though it's not green now, but I'll get into that. You go that way more and you do find some white oolites in green shale. Here, it has been oxidized really, really bad. That's what gives it this red, purple, and yellow colors. Now, like I said, this formation is oolitic, and I might take you a little bit to see some of that. So a lot of the calcareous oolites that were originally deposited in a shallow sea, not very deep at all before the seas were treated, they were calcareous. They became replaced with iron. So the white calcareous oolites became black hematitic ones. And we've seen this happen before, more modern times, like in Province Canyon, Georgia, which I've taken you to before. The basal tertiary formation, the Clayton there, has been oxidized in a similar manner, but there are fossils there that are totally replaced with hematite. It's really cool. So what's also really unusual about this formation is here it's only about 15 feet thick, 4 meters or so. Yet if you go north into Wisconsin, a long way north, you still see this formation. That tells us that this deposit was very extensive. And in Wisconsin, it's 3, 4, 5 times this thick, and they actually mined this stuff for ore. Here's the tree, and this is one of my favorite little structures in the basal Silurian. Contact between the Ordovician and the Silurian. How do I know the contact is right here and not up on top of this, and this isn't some paleotopography? Because of many field lines of evidence. Although this is a nice, relatively even contact here, the paleotopography wasn't that high. The hill, the paleotopographic hill at the end of the Ordovician that would have been part of this nita probably came up this way. And how do we know that? Well, we measure the dip of the beds. They do kind of dip a little bit that way and this way. So we did have some sort of hill here. Now, and it also makes sense because the river would have just cut through the weaker nita before the more resistant Silurian carbonate, the modern Kankakee River. But there's other lines of evidence. You look at this bed right here. It's very pitted. Now, remember, this was a mud when it was deposited, mostly shale, mud rock, but it was calcareous. So some of it did chemically weather out. You can see the pits here and stuff like that. But there's another thing that tells us this is the contact. You see this right here? You see these little tiny pebbles throughout here. They're just right here. That's it. They're not here. They don't progress over here. They're right here. Why is that? Well, we're going back to this cool looking structure here. Well, this bed wasn't altered tectonically later. It was deposited like this. How do I know? If the Paleo Hill was behind me, higher ground to the south, you still would have had on occasion, as the Silurian seas came back in, as the ice melted in the southern hemisphere, you would still get mud flows on occasion and storms and stuff like that, because this carbonate was not deposited in deep water. What you would have is mud from up higher on the hill on occasion, slump and slough down, even though the topography was only a couple meters or 6 to 10 feet, maybe at the most at this hill. And you get this mud flow. This would have been a mud flow that went this way. So this was deposited like this. It wasn't deformed later, and this isn't due to faulting or tectonic activity post-sedimentation. And then we had some nita incorporated right on top of it. A lot of iron staining right there that you don't see outside of the flow. And I just think that's really cool right there, because when I first came up upon this, it was hard for me to discern the contact, and that was how I figured it out.